Hello everyone, Ziaus on this side. So today we are dealing with a topic called as mechanism of concentration of filtrate. Okay, so let's get started. Now here the mammals have the ability to produce a concentrated urine, correct? Okay, so we are the mammals and we have the ability to produce concentrated urine. The Henle's loop and the vasa recta does play an important significant role for the formation of concentrated urine. Go through. Okay, now the flow of the filtrate in the two limbs of the Henle's loop is in the opposite direction and thus forms a counter current. Now, I'll be drawing in some like in this fashion. This is loop of Henle for me, and this will be the vasa recta. Okay, deal with. And if something is flowing in this direction in the loop of Henle and this direction again, in case of the vasa recta, it will be flowing in this direction. Okay, go through here. Now, this is the reason why we are calling it as counter current. Okay, the flow of filtrate in the two limbs of Henle's loop, that is called as a descending limb of loop of Henle and the ascending limb of loop of Henle, is in opposite direction and thus it is forming the counter current. The flow of the blood through two limbs of the vasa recta is also in the counter current pattern as well. So here the proximity between the Henle's loop and the vasa recta as well as the counter current in them will be helping in maintaining and increasing the osmolarity. Okay, now what does this osmolarity means? So basically it is the amount of the solute present in per liter of the solvent. So this is what we will be calling it as osmolarity. Okay, deal with. So increased osmolarity, which is helping the inner medullary interstitium. Do remember one thing, that the inner medulla. Okay, if somehow like I am drawing a structure and I am having a plane here which is passing from the radius. So this portion, this outer portion will be called as cortex. This central position will be called as the outer medulla and this portion will be called as inner medulla. Okay, deal with. So here the inner medullary interstitium. Okay, now from 300 milliosmol per liter in the cortex to about 1200 milliosmol liter in the inner medulla. Okay, so ultimately we do know that the osmolarity of the blood is 300 milliosmol. Okay, please do remember that the osmolarity of the blood is 300 milliosmol. But still, in case of the kidney, or ultimately if you will be dealing with the inner medullary portion, it becomes up to 1200 milliosmol. Okay, the osmolarity has been increased so much that the filtrate is having 1200 milliosmol per liter. Okay, go through. Now, this gradient is mainly caused because of the NaCl. This gradient is basically mainly caused because of the NaCl and the urea, two factors. Okay, the first factor I'll be calling it as NaCl and the second factor will be called as urea, the nitrogenous waste which has been excreted out of the body. Okay, deal with. Now, the NaCl is basically transported by the ascending limb of loop of Henle, ALH, ascending limb of loop of Henle, which is exchanged with the descending limb of vasa recta. Okay, so somehow if I'm drawing somehow like this is the loop of Henle and this one is the ascending limb, so ultimately here vasa recta will be there and the vasa recta is exchanging the NaCl along with the descending limb of vasa recta. So if we are having the ascending limb of loop of Henle, it will be exchanging the material with the descending limb of vasa recta. Okay, go through. Now NaCl is returned to the interstitium by the ascending portion of the vasa recta. Similarly, the small amount of the urea which is entering the thin segment of the ascending limb of loop of Henle, which is transported back to the interstitium by the collecting tubule. Okay, deal with. Now the collecting tubule will be something like that. At the end of the DCT, which is called as a distal convoluted tubule, there will be having the duct of Bellini, which is the connection of the DCT and the collecting tubule. Now, the above described transport of substances which are facilitated by the special arrangement of a loop of Henle and the vasa recta is called as counter current mechanism. Okay, it's called as counter current mechanism. So basically, in case of the medullary interstitium, the presence of such interstitial gradient help in an easy passage of water. Ultimately, this everything gradient case is helping for the easy passage of the water from the collecting tubule, thereby concentrating the filtrate. So basically the human kidneys can produce urine nearly 4 times concentrated than the initial filtrate formed. What was the initial filtrate? Here, this was 300 milliosmol, correct? And now at the end of the day it became 1200 milliosmol. So basically this is what it is written here, that the human kidney can produce urine 4 times concentrated than the initial filtrate formed. Okay, deal with the case. Now we'll be dealing with the diagram. So basically in this case what we have observed that this is our target area. Okay, this is what, this is basically the descending then the ascending limb of loop of Henle, and this is the vasa recta, correct? Okay, now the proper position of vasa recta is something like this. Okay, deal with. So the proper position of the vasa recta is something like this. This vasa recta, whatever we are observing here, it's actually here. Okay, go through. Now what is here? First thing we'll be dealing with the ascending loop of Henle. So here you are observing that two lines have been drawn here, first and the second. Why? Because the initial filtrate was having the concentration of 300 milliosmol per liter, then the final filtrate has 1200 milliosmol, and in between we had 600 milliosmol and the 900 milliosmol. So how come the concentration is getting increased? So basically, for an example, if I'll be taking the example, how come the concentration of the solution has been increased? So if I'm making a solution in which the solution is basically made up of two components, right? The solute and the solvent, correct? Okay. So here, if I'm having, let's say 10 gram of solute, okay? 10 gram of solute plus 100 ml of solvent, okay? Deal with. Now, if I'm removing the 100 ml, like the 90 ml from the water, now I'm having 10 gram solute plus 10 ml of solvent. So ultimately we will be coming onto the conclusion that yes, the concentration of the solution has been increased, and the same case is getting repeated here in the nephrons, here in the renal tubules. What's happening here? How come the concentration is getting increased? Because they are just removing the water, or they are just absorbing the reabsorption. Okay, selective reabsorption. So basically here the NCL is playing a lot of different roles. So here like the NCL is getting reabsorbed by means of vasa recta. Okay, so this like NaCl which is present here in the ascending limb of loop of Henle, it is coming out of the ascending limb of loop of Henle and it is getting absorbed in the vasa recta. And the same case if I'll be going through again, like in case of the vasa recta, the flow of the filtrate is something in this direction, correct? Because you can literally observe that the 300 milliosmol, 400, 400 to 600, then 800, 1200, 1800, 600, 400, and finally 300, and it will be going again from the efferent arteriole. From the efferent arteriole, do remember one thing, the efferent arteriole is something, the arteriole which is bringing blood towards the glomerulus, whereas the efferent arteriole is something with the arteriole which is taking blood away from the glomerulus. If afferent towards the glomerulus, efferent away from the glomerulus. Okay, deal with. One extra thing you will be observing here, that yes, a little amount of water is also getting reabsorbed by means of collecting tubule. Okay, deal with. So here, whenever the DCT has passed its all filtrate, again in case of the here, like again like in the starting portion of the collecting duct, here we have the concentration as 300 milliosmol, but still as the filtrate is getting passed in the forward direction, the more and more amount is getting reabsorbed in the interstitium, and our urine will become more and more concentrated. Okay, more and more concentrated, and a little amount of urea is also reabsorbed here. Please deal with the case. Okay, now, so what is the final concentration of the formed urine? It will be 1200 milliosmol. Okay, it will be 1200 milliosmol per liter. Okay, But one extra thing I want to tell you, that please do remember, in limited in limited fluid intake in limited fluid intake, the human urine can go up to as high as 1200 milliosmol per liter. Okay, in limited fluid intake, the human urine can go as concentrated as 2400 milliosmol per liter. Okay, deal with the case. So hopefully this lecture has been beneficial for you guys. Thank you very much for your so much support. If you do have any kind of questions, you can ask me there in the comment section. Thank you.